Good morning. I just wanted to show you around the interactivity that I'm posting this week, which is called Solar Oven Design. It's the only Pearson assignment that I'm giving this week. It has a couple parts to it. When you open it up, the overview says, how do you design an oven to run on solar power alone? We're not talking about solar panels here. The simplest solar oven is just a box with a window in the top to let in sunlight. But in order for the oven to get hot enough to actually cook food, you need to understand the different factors that contribute to the oven's design. In this activity, you will simulate controlled experiments to test some of the factors that affect the performance of a solar oven. In the beginning of the year, we talked about what a controlled experiment is. In a controlled experiment, only one variable is changed, and that's the independent variable. So everything else remains constant. So you'll have a lot of factors held constant. This simulation calls those controlled variables. We call them factors held constant. The simulation data will help you design a solar oven that maximizes the amount of energy transfer needed for cooking. Don't worry about the worksheet. I just want you to kind of play with this. This will review energy transfer, and it'll also review designing controlled experiments. So there's the learning outcomes, and this is the actual investigation. There's a couple different parts to this because they want you to test a few different variables. In part 1, a solar oven is a device that converts solar energy into thermal energy. You can make a simple solar oven out of a cardboard box. Here's how it works. Sunlight enters the box through a hole in the top and is absorbed by the box's interior surface. Painting the inside of the box black or lining it with black paper helps convert more of the incoming solar energy into thermal energy. Think about when we did the penguin activity and the penguins were put into those heat boxes. To help prevent heat from escaping the oven, the hole is covered with a sheet of clear plastic. What makes a solar oven design successful? The main goal of the design is to achieve oven temperatures hot enough for cooking. But there are other criteria too. For example, many users of a solar oven would expect it to be portable, reusable, and made of low-cost materials and easy to set up. And then they talk about constraints that restrict the design. So local weather, climate, cost, building materials, etc. So we'll be examining 4 different components: window size, box height, box thickness, and the use of reflectors. All right, so for each of those different variables that you're going to change, remember it's a controlled experiment, so you're only changing one at a time. You're going to make a prediction. The first design variable you will investigate is the size of the window and top of the oven. Does changing the window size affect the oven's performance? And if so, how? You will simulate a controlled experiment by collecting oven temperature data for different window sizes. So first, make a prediction. Let's say I think that making the window bigger, so increasing the size, will improve the solar oven's performance. So I click on that and hit next. And then it tells me a little bit about that. For the solar oven simulation, we'll use a cardboard box with dimensions of 40 by 40 by 5 centimeters. Based on these dimensions, the largest possible size for the window is a square with 40 centimeter sides. The manipulated variable, or the independent variable in this experiment, is the length of the window side. Assume the window remains a square. The responding variable, or dependent variable, is a maximum solar oven temperature. So that's going to be recorded right here. Click on the table icon to view the controlled variables in the experiment. That's over here. If you don't click on this, you won't be able to go on. So they just want you to see, okay, these are all our controlled variables, or what we call factors held constant. And then the slider appears and you can change the length of the window. So I can change this to 10 and click collect data. And then I can change it to 20 and collect data. 30 and collect data, and 40 and collect data. They want you to do at least 3 points. And then I can look at what happened. And if this were connected, you can see the trend going up here. So as the length of the window increases, what's happening to the temperature? Well, the temperature is increasing. So how did my prediction compare to the data I collected? my prediction was correct because I said that increasing the window side would increase the temperature, which increases the effectiveness of the solar oven. All right, and then it goes to a different variable. Now you're looking at the height of the box. Make your prediction. Let's say, and then it says to click on the controlled variables so that you know, okay, these are all my factors held constant, things that are staying the same throughout the experiment. And then the slider pops up, and now I can move that and collect data. And collect data. And then you can see the graph, what happens as you are increasing the height of the box. So now you see the trend that the temperature goes down as you increase the height of the box. And then there's two more variables. And then you can hit this button here to save your data. Your work is saved. You may now exit the lab. And then I'll ask you some questions about that. Okay? Thank you.